Hello everybody, this is Cameron Snow with Danomics.com. In this video, I'm going to be going over how to use our new Tops to Structure Grid tool. What this tool does is it allows you to make structure maps, and it guarantees that it will honor geological principles in that none of the structural surfaces will be allowed to cross one another. What we're doing here is we're using Danomics' new internally developed constrained kriging algorithm to ensure that when you have sparse data, that it forces your structural grids to follow geological principles and to not cross one another. So that is, we make sure that the implied isopach thickness is always greater than or equal to 0. All right, so let's get started. So as you can see here, I have a cross section pulled up, and I've picked my tops in this area. This is in the Powder River Basin, Wyoming. So I've picked my tops here. You can see that in some wells, I've picked a top that's not present in other wells. I want to highlight that because we'll talk about the implications of that a little bit later here in the video. But what I want to do now is the first step that a lot of geologists will do after they've picked their tops, which is generate structure maps. So we've had a way to do this in Danomics for quite a while, but this new and improved method, like I mentioned, ensures that none of your structural grids will cross when you start to get farther away from well control. So how do we do this? What we'll do is we'll need to do a few things. So I'm here in this folder called Geoscience, and when we're doing this, we're going to need to work in real coordinates. So what we'll do is we'll start off by creating a projection. So we're going to right click on the folder and we're going to say edit projection. And it'll ask us if we want to create a new one, and we're going to say OK in this case. And I'm going to use a PRJ file here. You could just run with WGS84, but I'm going to choose a specific PRJ for this area. So I'm just going to click on that here. There we go. And I'm going to choose that projection file. And you know, it gives me a little bit of a preview here if I want to see that, but I'm just going to save it. And now I can close that. So now what I'm going to do is I'm going to right click again and say new flow. And I'm going to call this structure gridding and hit OK here. Now in this flow, what we're going to do is we're going to start off by bringing in our tops. So I'm going to say points input because tops are like points data, and we are going to choose our these powder area tops here that I've picked. Okay, and the next thing we're going to need to do, because all those tops are in measured depth right now, there is no location information associated with tops. So we are going to use our tops to TVD tool. And this tool does two things. It brings in our well headers. So we're going to grab our well headers here. And in this case, I've already brought in some deviations and processed those. And so I'm going to grab my process deviations here. And this will make sure that if I have deviated wells, that I'm putting everything in the correct XYZ space. Next, I'm going to use this new tops to structure grid. And as of the time of recording this video, this tool is still in what we would call the experimental phase, which means that there may be some future updates that may not support backwards compatibility entirely. Once we do a little more testing on this and it goes through a few more users, then that tag will be removed and the tool will then be fully supported here. So what do I need to do? I need to come here and just play match the columns. So our value column will be Z. We'll have our formation here. So that's our formation, our API. We are going to put this in X, Y, and we're going to take our X and our Y columns, and it's going to be using, for our projection here, it's going to be using the project projection. And now we're just going to end with a grid output. Okay, so this is the most basic form of it, and I'm going to hit the run button here, and we're going to talk about a few upgrades that we could add to this flow potentially. So um, you'll notice that I mentioned here in the CPI that there are a few tops in here that were sparsely picked, such as the lower Parkman formation. I didn't pick that in every well. So what if I wanted to, uh, you know, leave that formation out? Let's say I didn't think I had good control on that. Maybe it's not a consistent marker. Let's say I wanted to change that. Well, what I could do, I come over here to points select, and I could put this point select in. I'm going to move it up to be behind my tops, and we're going to say, filter by value, column formation, and then we'll choose the formations that we want. So in this case, I'm going to choose the Lewis, the Parkman, Teapot, Sussex, Shannon. I basically choose the formations that I want to keep here, and this doesn't have to be in stratigraphic order. It's just choosing what we want to keep. And so you could keep as many or a few of these as possible, but in this case I'm omitting that lower Parkman. So that way I'm not going to generate a structure grid on that. So that's one added piece of sophistication we could put in there. We could also add a, if we wanted to, a point spatial filter block. Point spatial filter is designed to help you remove outliers from your data based on their neighbors. Um, so in this case, if I wanted to look at this, maybe I'm going to look at the, let's say the closest 11 wells, and I'm going to look at the, the P10 and the P90 exactly, so the point would have to fall on that. That helps clean up outliers before it goes into this tops to structure grid. And, if we're worried about, maybe what is our, maybe our grid's a little rough in here, we could always add a grid smooth step in here before we have our grid output. And then once again, I'm just going to give this a new name, so it'll write another file, and we're going to hit run here. Now we see that first one has finished, and we have this new structure gridding .grid here. So I'm going to click on this, and what we'll see is in this .grid file, we did this not just for one formation, but for every formation here. So we've got all this here, and this is just a preview window of that grid, just to help you QC and make sure it ran as expected. So now what we're going to do is we're going to display this on a map. We're going to go File, New Map, and I'm going to just call this PR Map. Hit OK. And I'm actually going to highlight a couple of features here. To get started, what I'm going to do is I'm going to add just some well markers real quick, and I'm going to add a subset of my well headers here. These are the ones that I know have that are kind of in my area of interest. So we've got those added, and now I'm going to add a property, and the property that I'm going to add is this new structure gridding file. And let's say I want to add the Niobrara formation. Give that a nice color here. And for my contours, I want a 250-foot contour interval. Let's say add, and here we go. Now we have our structure map in TVD sub C here. All right, so that looks nice. Now let's say I want to look at this as in either a 2D or a 3D window. Well, how can I do that? No problem. I'm going to say split window here, and once I do that, I can come back up here and I can say add tab, and I could add, for example, a 3D view. So now I've got this 3D view. I'm going to add our grids here, and let's say I want to look at the let's say the Niobrara and maybe the Parkman here. So I'm going to add those two. Let's put the vertical exaggeration up a little bit so we can really see what's going on. Okay, so we've got our headers, but we don't have, and our grids, but we don't have the well bores. So to add those, we're just going to say well bore, and we're going to choose, once again, these model wells and our process deviations, and we're going to hit add here, and now we've got, well bores in here for all our wells. Okay, so that's pretty cool. Let's say we want to look at this as more of a kind of like a 2D slice instead of a 3D view. Well, how do we do that? Once again, we can come here and we can say add tab, and I'm going to add what we call a projection view. And you'll notice this view starts off kind of messy here. So we're going to clean this up. And what I'm going to do, you'll notice we now have this box over in the map window. I am going to click on this little slider bar here. I'm going to make this box relatively thin, and I'm going to widen it up. And now I'm going to drag it up here, and I'm going to set this to go from 0 to minus 10,000 feet. And now what you'll see here is we have a kind of like a slice view or a structural cross-section view of our structural grids, in this case for the Parkman and the Niobrara with our well bores. And if we wanted to, we could even add well logs to this view if we have that data available. All right, so that's it for this video. Just a quick review of the structure gridding flow. We started off with our, and we're going to go back to the simple version of this, just for the summary. We start off with a points input where we grabbed our tops. Then we went to tops to TVD, where we brought in our well headers and applied our deviations. Then we put this in the tops to structure grid, where we mapped out our columns, so X, Y, and Z, as well as API and formation. And then we wrote out our structure grids here. And that was it for this flow. All right. I hope this was useful to you. If you have any questions, you can always reach out to us at support@danomics.com. Thank you.